In our previous class, I introduced you to set theory. We looked at the various set notations. We also talked about the forms of sets to include set builder form, and of course we talked about the tabular form of sets. In our class today, I'll be talking about Venn diagram. Is that okay? It's a diagram proposed by an English mathematician by the name John Venn. This Venn diagram can also be used in analyzing set problems. Here on the board, I have these various Venn diagrams. Now we're going to talk about each of them quickly. Okay, first we have here is A intersection B. When the elements of A, you have those of them also in B, common element. Using our Venn diagram, this is how we draw it. This portion that I use red marker to shade is A intersection what? B. So the elements that A has and B also have, those elements will be written in this portion. This rectangle represents universal sets, and of course, you know our universal set, we use this symbol or this symbol. The rectangle represents universal set. Let us look at the second one, A union B. This is how the diagram looks like. You can either use this or you use this. Remember that in this case, all the elements of A and B are put together. Alright? And that is why I shaded everything in A and in B. So any element found in A and B together, including their intersection. Are you following, right? Those elements form part of A union B. So in dealing with Venn diagram, when you write any element within this space, that element belongs to the set A union B. Let us look at the next one where we have three sets. And these three sets, they all intersect. Okay, so we have A, B, and C. A intersection B intersection C. On the board here, number 3, I have the Venn diagram to that. This portion shaded, alright, with this red marker shows A intersection B intersection C. So all three sets, there are elements that are common to them, has to be written here. Is that okay? Now, I want to say something quickly here because when dealing with Venn diagram, problems given at times, you hear words like A only, A and B, you know, A and B only, C and B, and things like that. How can we show that in this diagram? For example, when I want to consider the elements that belong to set A only, so you don't have anything to do with set B and C. So A only, you can say it is equal to A intersection B complement, meaning it has something to do with B. Intersection C complement, meaning that it has nothing to do with C. So that belongs to A only, and that's what we write here. Any element found in this space is element belonging to set A only. We can do same for set B only, alright? That's going to be B intersection A complement. It has nothing to do with A. Intersection C complement. It has nothing to do with C. And those elements are the element written in this portion, okay? Then you can do similarly for C. C only will be equal to C intersection A complement intersection B complement. Alright? So any element written here, and written here belong to these sets only. Is that okay? What about maybe elements that belong to A intersection B in this case? So let us see that A intersection B. That is element belonging to A and B only. A and B only. In that case, of course, it means that C has nothing to do with this element. That will be given as A intersection B and then intersection C complement, meaning that C has nothing to do with this element in A and B there. And those elements in that case is found here. Look at here. This portion. This portion is A intersection B. You notice that they meet at this point. At this point, look at it. So any element written here is A intersection B. It has nothing to do with C. Alright, you can also do same if you want for B intersection C. In that case, that is B and C only. B and C only. And of course, if you're working it out, it's going to be B intersection C, then intersection A complement. It means it has nothing to do with A. And of course, that is going to be written here, this portion. This portion. You can see where B and C, where they meet. So any element written here is simply the element belonging to set B and C, but has nothing to do with set A. In a similar way, you can write for A intersection C. Let me do that here. A intersection C. That simply means A and C only. A and C only. And what is the implication? It means that this element will be A intersection C and then intersection B complement. It has nothing to do with B. We'll deal with this when solving problems on Venn diagram anyway. So let us move on to the next one, number 4. A union B union C complement. That simply means elements that do not belong to A, B, or C. They have nothing to do with this set, ABC. Those elements are written inside this universal set. Is that okay? Any element written in this shaded portion is element which belong to the set A union B union C complement. And like I said, it simply means that A, B, C do not have these elements. We move on to the next one, difference of two sets. Difference of two sets. I explained this in the previous class. These are the elements that belong to A but do not belong to B. If I write it as A minus B. And in this case, it's still the same as A intersection B complement, or A only. Now in this case, there is nothing like drawing this rectangle representing universal set because they are just dealing with two independent sets. Alright? So let's look at this. This is the diagram to that, okay? This shaded portion represents A minus B. As a quick example here, you have A to be the element 1, 2, 3, 4, and B to be the element 1, 4. You see clear that B, the elements of B are in A, but not all elements in A are in B. So those elements that are in A, but not in B, are the elements in the set A minus B, and that is simply 2 and what? 3. If we choose to do B complement now, because looking at A and B, set A and set B, you agree with me that set A is like a universal set to B. But like I said, we don't use that word when dealing with difference of two sets. These two sets are independent sets. Is that okay? Now, if I find B complement in this case, for example, knowing that all the elements in B are in A, but not all the elements in A are in B, you'll agree with me that B complement is equal to the element 2 and 3, okay? Now, that being the case, what if I say, okay, let us find A intersection B complement? A intersection B complement. That's going to give us 2 and 3 as well too. And that is why, in this case, I wrote that A minus B is equal to A intersection B complement, okay? Alright, let us look at number 6. In that number 6 here, we have A intersection B, giving us an empty set. So if you give it a set such that the intersection of the two sets is an empty set, that simply refers to disjoint sets. It means that these two sets do not have any common element, and so they will not meet, they won't intersect. The diagram is what we have here, okay? You can see clearly that set A and set B do not meet. That takes us to the next set, the Venn diagram here. We have B as a subset of A. How do we show that on Venn diagram? You can say that where B is drawn inside set A. That simply tells us that B is a subset of A. We're going to pick questions now from different exam bodies and then see how we can apply this knowledge of Venn diagram to solve problems on sets. In this video, we're going to learn how we can apply the knowledge of Venn diagram to solve problems on set theory. Here on the board, I've got this white question, year 2017, question number 5, theory. And the question reads, out of 120 customers in the shop, 45 bought bags and shoes. If all the customers bought 8 bags or shoes, and 11 more customers bought shoes more than bags, I illustrate this information in the diagram. I find the number of customers who bought shoes. I calculate the probability that a customer selected at random bought bags. So let us see how we solve this problem, okay? In the first part of the question, we are asked to illustrate this information in a diagram. And of course, we are going to use Venn diagram to show this information. But first, let's get to know the subset of the universal sets that we have here, alright? Now, this question deals with set of bags and shoes. So we have 2 subsets there. Is that okay? The total number of customers in that shop is 120 customers. Therefore, the cardinality, alright, of this set is 120. The first part of the question, let's see what the Venn diagram is going to look like. So I'm going to draw my universal set. This is the universal set. You use a rectangle to show it. The cardinality of the universal set. Cardinality of the universal set is equal to 120. You know the meaning of this symbol by now, okay? Alright, now, since we have two sets here, set of bags and set of shoes, I am going to draw two circles in this universal set. One representing bag, the other representing set of shoes. But I want to find out something. Will there be an intersection where these two sets will meet? And from the question, I think I would say yes. Why did I say that? 45 bought bags and shoes. So out of these 120 customers, 45 of them bought bags. They also bought what? Shoes. So there are actually a number of customers there who bought bags and shoes together. And that is the intersection of bags and shoes. So I'm going to draw this and then show the intersection. At the point of intersection here, I'll fix 45. Let this represent the set of bag and then this the set of shoe. I'm using B and S for it. This portion I'll record 45. I'll write 45 there. That's the number of customers who bought bags and shoes. Alright, let's move on. If all the customers bought either bags or shoes, the word either means these customers, if they bought bag, they will not buy shoes. Or if they buy shoes, they will not buy bag. That is the implication of either. And at this point, I want to say without mincing words, that you need a good understanding of English language so as to be able to interpret problems on Venn diagram. That's the truth, okay? But it's not difficult anyway. Besides, we'll learn English language. That's good. Okay, now let us move on. We don't know the number of customers who bought bags. We don't know the number of customers who bought shoes. And so we are going to use an unknown, say X or Y, any alphabet you want, to represent the number of customers who bought either bags or shoes. But then, student, watch something here. 11 more customers bought shoes than bags. So if I decided, okay, X number of customers bought bags and bought shoes, you want to remember that we have 11 more customers. So the number of customers that bought bags are more than the number of customers that bought, now the number of customers that bought shoes are more than the number of customers that bought bags. They are 11 more than. Alright? So I will come over here and say, okay, let X number of customers buy bags. And then here will now be X plus 11. Alright. I've successfully interpreted the information in this Venn diagram. So we are moving on to the second part of the question. The second part of the question, we have to find the number of customers who bought shoes. Now from my Venn diagram, number of customers that bought shoes. Number of customers, okay, that bought shoes. According to the Venn diagram is X plus 11. And we don't know this number of customers. Is that okay? Now for us to obtain this X plus 11, the value, and know the number of customers who bought shoes, we need to know the value of X. So I will solve for X by writing. But I know to get X, if you add all these numbers here, this, and this, it should give you the cardinality of the universal set 120. So I'll write is equal to 120. So that leaves me with, if you solve for X here, X plus X will give us 2X, because 45 plus 11 is going to give us about 56. That 56 will cross over, you have 120 minus 56. And so 2x will give us 120 minus 56 will be equal to what? 120 minus 56, they're about 64. Let's find out. 120 minus 56 is equal to 64. So 64. What will now be the value of our x? I'll divide both sides by 2 to get my x. So x is equal to 64 over 2, which is equal to 32. So you see, the number of customers who bought bags only are 32. But anyway, the question didn't ask me to find that, focusing on what we are looking for. In the second part of the question, we have to find the number of customers who bought shoes. So I can now write, it implies that number of customers who bought shoes, x plus 11, will be equal to 32 plus 11. And that will give us what? If you add up this, you get 43 customers. Alright, so 43 customers actually bought shoes. Answer. I'm moving on to the third part of the question. In the third part of the question, we have to calculate the probability that a customer selected at random bought bags. Now, the knowledge of probability is required here. And you know that probability of any event mathematically is equal to the probability that event occurs divided by the total number of trials that you have there. Here, the total number of customers is 120. So the probability that a customer selected at random will buy bags will now be the number of customers who bought bags divided by what? The total number of customers there. Permit me to write probability, okay, of customer buying what? Bags. So probability in brackets, bags, is going to be, let us find out how many customers actually bought bags here. You can find the customers here, X number of customers bought bags. Then remember that number of customers who bought bags also appeared in this intersection, 45. Therefore, that is going to be X plus 45 divided by the total, which is cardinality of the universal set. And so if you work out this, our X is 32. That's going to be 32 plus 45 divided by 120. This will give us 77 over 120, which is equal to 77 divided by 120, the result, 0.6417 approximately. If you're solving something theoretically, it is usually advisable to leave your answers in 4 decimal places, okay? Equals 0.6417. If you like, you can translate it to percentage by multiplying this number by 100. If you do that, you get 64.17%. And of course, that's the answer to the third part of the question. And you can see how we've used the knowledge of Venn diagram to solve this problem. Next on the application of Venn diagram is this Unisic question. Here on the bar, we've got this 2014/2015 past question, number 19 and 20, its objectives. So let us read the question and see what is required of us. Out of 1,000 students applying for admission into the Faculty of Biological Sciences in NAU, Nnamdi Azikiwe University, Awka, 300 applied to read botany, 340 applied to read zoology, and 309 applied to read parasitology. 100 applied to read botany and parasitology, 128 applied to read botany and zoology, while 120 applied to read zoology and parasitology. If 380 do not apply to any 3 departments, how many students applied? The first part of the question, only into 1 department. We've got these options here. This is objective question. And then the next question, or the next part of the question is into the 3 departments. We've also got the options there. So how do we solve this problem? I want to say this, that using the idea or knowledge of Venn diagram solve this problem faster. Or actually, we can decide to approach it mathematically without diagram. Using the idea of all these intersection, union, universal set, complement, but that would rather be quite complex, and the eyes wouldn't even like to see what would happen in that case. And so I always advise, when you have problems like this, quickly analyze it using Venn diagram. Is that okay? Now you see how your result comes out immediately. First of all, we get to know that this problem, okay, the universal set, its cardinality is 1,000. That's the total number of students that applied to Faculty of Biological Sciences here. And then let us also find out how many sets do we have here. How many sets, okay? The subset of the universal set. The student that applied into this Faculty of Biological Sciences. In that faculty, some of the students applied to read botany. So that will form one of our subsets of the universal set. And then some of the students also applied to the Department of Zoology in that biological faculty, giving us what? Subset 2 of the universal set. And then some of the students applied to Parasitology Department in Faculty of Biological Sciences, making it what? Subset number 3 of the universal set. So here we actually have 3 sets. Is that okay? And so I will draw, I've got this, and then I've got this. So I'll enclose it in my rectangle. Okay, so this, close it in my rectangle. Or something like this, okay? In objective case like this, I mean, it's not relevant drawing all these rectangular stuff for universal sets. It's rather going to waste your time, okay? You can just draw these circles and proceed with your analysis. So this is my universal set equal to 1000. Let me take this set to represent those that apply into botany department, then this into zoology, and then into parasitology. A very big secret. When analyzing Venn diagram, it is best to start from the inner portion of the intersection, the core. So where all three sets intersect, start filling from there and then expand outward. If you do that, the problem will just be very simple. So we're going to start from the portion, the region where all three sets intersected. And if you look at this question here, we don't know the number of students there. The student that apply to all three departments, we don't know. So I'm going to call it X. Is that okay? I'm going to call it X. Okay, from there we now move outwardly to where we have the intersection of two sets. That's the next thing. I will speed up a little now. Remember, first, the intersection of all three sets. And then you move outwardly to the intersection of two sets. You move again to where none of the sets intersect. That is, you now deal with only the number of students applying to a particular department. So in this case, I'm going to look at this portion now, this, because these are the portions where two sets intersected. All right, I'll go back to my question. I'll search for where I have that information, number of students applying to two departments. So let us see. Think we have here that 100 applied to read botany and parasitology. So I will locate botany intersection parasitology. 100 applied to read. Another important secret. Be taking note of this secret. They are wonderful points you don't need to joke with when working with Venn diagram. We are told that 100 applied to read botany and parasitology. There is nothing like only attached to that statement. Suppose we were told that 100 applied to read botany and parasitology only, I would come here and just fix 100. But because we're not told only here, it means in this 100 students that apply to read botany and parasitology, chances are that among them include those that apply for all three departments. Therefore, this is what we do. We'll come over here and then put 100 minus x. Look at the intersection of botany and parasitology went this way. Just watch what I'm tracing. Okay, this is it. You notice that this closed part enclose your x, and therefore if you fix 100 here, you are meant to remove that x from it. 100 minus x, and I've told you the reason why. There is no such word as only there. All right, which means this 100 is not pure. In this 100, some of them also apply to all three departments. Having stated this secret, we'll now move on to see 120 applied to read botany and zoology. Once again, nothing like only. If we had only there, I would just go to botany and zoology and write 128. I wouldn't subtract anything. But because there is no such word as only after the statement 128 applied to read botany and zoology, it means I will come to botany intersection zoology 128, and then I would subtract x from it. But let me use blue marker to show the subtraction. I'll subtract x from that, because once again notice that botany intersection zoology, if you trace the enclosed part, it covered x as well too. So you need to subtract that x, okay, from that 128. We move on to the next. We have that 120 applied to read zoology and parasitology. So I will locate zoology intersection parasitology. I'm going to write 128. Once again, there is nothing like only there. Please take note. If we had that word only, I'll just come here and write 120. I'll come to zoology intersection parasitology. The close part there, 120, I'll leave it if there is only there. But unfortunately, that word only was not used. Therefore, I will subtract whatever that this zoology intersection parasitology encloses, whatever it covers. And if you trace this intersection from here, you notice that it covered this x. So it's going to be 120 minus x. Good. We're doing great here. Let us now move on. We are done with where we have two intersection sets. So we're now moving on to number of students that apply to just one department only, which now has to do with this part, and this part. So I'll go back to my question. and then search for where I have that information. 300 applied to read botany. To read botany. Question, did you see any word only there? Like 300 applied to read botany only. There is no such word. Therefore, this 300 is not pure. There are still some among them that apply possibly to read another course. Is that okay? And hence, I'm going to come to that set of botany. I'll write 300, okay? And then I'll do minus. I will trace the set, that circle of botany. Anything it encloses, any number it covers, I will do what? Subtract it from this 300. So let us quickly take a look. You notice that as this thing goes this way, you have 128, it enclosed it. If you move on, it also encloses x. If you move on, it encloses 100 minus x. So you're going to subtract all these numbers from this 300, okay? So this is 300. So it's going to be minus 300 minus, the first it enclosed here is 128. So 128 minus x. It enclosed that, okay? It enclosed that. So you subtract it. And then again, you notice that it enclosed x here, so you're meant to subtract that x, so minus x, and you notice again that it enclosed 100 minus x. So I will still do that subtraction. Minus 100 minus x. 100 minus x. When working on this, it's very good that you make use of your brackets, okay? Remember that if you have minus outside the bracket, it changes the sign inside the bracket, so it's very good for you to do that. So this is 300 minus all the elements, all the numbers enclosed by botany. And you know the reason why I did that subtraction, I've explained that. There is nothing like only applied to these 300 that apply for botany here. So I move on to the next. 340 applied to read zoology. Again, there is nothing like only. So I'm going to do 340 minus all the elements enclosed by the set of zoology. So this is zoology. I'm going to write 340. So let's start our subtraction. Minus. Okay, so let me just walk straight on with black marker. What numbers are enclosed by this set of zoology? Look at it. 128 minus x is one of them. The next one is x. And then the next one is 120 minus x. So it's going to be minus open bracket 128 minus x. Then minus open under bracket. Okay, this is just minus x there. Minus x, and then minus, I'm going to open the last bracket there, 120 minus x. So these are the whole term I'm meant to subtract from 340. And then lastly, we have that 309 applied to read parasitology. 309 applied to read parasitology. So 309 minus, remember there is nothing like only used there. So I'll subtract all the numbers enclosed by that parasitology set. So 309 minus, if you trace it, you have 100 minus x, enclosed in bracket, and minus this x because it enclosed that x. And then finally, minus this 120 minus x because it enclosed that number as well too. We've illustrated these on the Venn diagram, is that okay? And so with this information, we can actually proceed and then solve to obtain what we are required to find. But take note that here we have if 380 do not apply to any three departments. So we have 380 students that did not apply to any department at all. Where do we fix that number? I'll come over here and put it in the universal set. 380 students did not apply to any department. Alright, so from here, let us solve for this x. Once we know that x, we can now obtain what question 19 and 20 is all about here. Okay, so let's go. How do we get our x? I'm going to add up all these things and then make it equal to 1000. We go 300, then minus, but I can actually choose to work this one aside, just get the value so that it will not be too stressful. Okay, let me just draw something here. From this way, I would bring it out. Let's know what the value is. 300 minus 120 is, if you work out this, 300 minus 120. Remember, this minus here will change. This is 128 rather. This minus will change to plus. And then if you come here, minus 100, this minus x will change to plus x. So let us see what that will give to us. 300 minus 128 plus x. Okay, let me keep that x aside. I'll work it out as a like term of the other x. Then I'll come here minus 100. And this gives 72. So I'm going to write 72. What I have here is 72. Then this is going to be plus x minus x gets to 0, then plus x. 72 plus x. I'll come over to parasitology and do same. Let's know we'll have the 309 minus 100, 309 minus 100, and then minus 120, minus 120, and that gave 80, okay, that gave 89. And then if you work with the x, this minus, we change this minus to plus, so this is plus x, minus x goes to 0, then minus will affect this minus x here to become plus x. So this is 89 plus x. I'll move on to that of zoology and do same. That of zoology, we have 340 minus 128, then minus 120. That gave 92. 92. Again, if you work out that of x, this minus will change this minus to plus. You have plus x here, then minus x goes to 0. This minus will change this minus x, you get plus x. So I've reduced those terms. I can now solve for x. Solving for x. This is going to give to us that 72 plus x, which is the element in this set, number of students in this botany set only. Then plus, I'm going to have 89 plus x for parasitology only, plus that of zoology only is 92 plus x. Then I'll move inside where we had intersection of two sets. Here this is 128 plus 128 minus x, and then plus 100 minus x, and then finally we have plus 120 minus x. That in the case of those that apply into two departments only. And then plus, I'll move on to all three departments, which is x. That is expected to give me, okay, we have another student here, those that didn't apply to any department, 380. The total should give me 1000. Let's work this out and see. If we open up this bracket, you have 72 plus 89 plus 92 plus 128 plus 100 plus 120 plus 380. 72 plus 89 plus 92 plus 128, then plus 100 plus 120 plus 380. So this gives 981. 981. Let's work out that of x. This is plus x giving us 2x. This one 3x. 3x, this will be minus x, making it 2x. Minus x, making it x. Minus x, making it 0. Plus x, making it plus x, and everything will be equal to 1000. It implies that x will be equal to 1000 minus 980, which is 19. Therefore, there are 19 students that did not apply. Oh no, there are 19 student x that apply to all three departments. And of course, that answers question number 20, you know. So I can actually put that, question 20. 19 students, x equal to 19. Therefore, 19 students apply into all three departments. All right, we've obtained the value for this second part of the question. Answer. Now we'll look at question number 19. But before then, the correct answer is option D. So let me put that, option D. That's the correct answer in question number 20. Then I can answer question 19. Question 19 requires that we find the number of students that applied only into one department. Only into one department. Only into one department would be that the student applied only into botany, or only into zoology, or only into parasitology. That's the interpretation of that. Is that okay? So number of students that applied only into one department. Permit me to write number of students into only one. So that is going to be equal to number of students that applied only to botany. So it's going to be botany only, B only, or it's going to be zoology only, or it's going to be parasitology only. And of course, when you have or, the interpretation of that under certain probability is plus. So this is now going to give us, this value is botany only. So that's going to be 72 plus x. And what's the value for our x? 19. Then plus those that apply to zoology only, that's 92 plus x. 92 plus x, and x is 19. And then plus those that applied into parasitology only, which is 89 plus x. and x is what? 19. So if I add up this, I should get my answer. Let's find out. 72 plus 19, and then plus 92 plus 19 plus 89 plus 19 equal to 310. 310 students apply to only one of the departments. Answer. And this goes with option what? That goes with option B. So option B is the correct option there for question 19. And of course, I've given you a full load of how to analyze set problem using Venn diagram. Take note of the key points I highlighted when you hear the word only. Very important.